Right, so in this problem, we're asked to solve for the equilibrium expression numerically. If we look at the information given to us, we're actually only given the delta G values of the substances in the nitrosyl chloride formation reaction. So what that means basically is we have to solve for the delta G of the reaction, and when we have that value that way, using this equation right here, we can solve for the equilibrium constant K. Alright? Okay. So our delta G values for the reaction, now if you remember the equation, it's products minus reactants. Since we have 2 moles of the nitrosyl chloride, we multiply the delta G of the nitrosyl chloride by 2. And we subtract it by the sum of the delta G's of the reactants. And we will get a value of 45.89 kilojoules per mole. Okay? Okay, so now we can use the equation to solve for K. So just to make things easy, I like to plug and chug. So I like to put the variable that I'm solving to one side. Now, the reciprocal of the natural log of something would be putting the everything on the other side of the reaction, put e to the exponent of that. Okay, so K essentially is equal to e to the negative delta G over RT. Alright, that's basically, and remember it's negative, okay, because in the initial equation, delta G is equal to negative RT times the ln of K. Okay, so after we put everything to one side of the reaction, because again we want to isolate K, this is how you just get K by itself. You put these terms here, you put e to the power of these terms here, okay? It's really not that bad, but that's just in case if you didn't know that. So again, our delta G is 45.89, R is 8.314, and T, we're using, again, this is standard temperature and pressure because we're under standard conditions. It's equilibrium. So it's 273.15 Kelvin. We raise e to this, and what we get is 0.9799, but, and there's another 9 there, but again, the question asks for it to 3 significant figures, so it's 0.980. Okay? Hope this helped.